Hi, everyone, and thanks for joining us today. I really appreciate your taking your time. It's a pleasure to be here, and sorry for the past minutes I've been talking on mute. Well, we are going to share a bit more about what we've been building at Readyset. Over the past months, we've been working closely with teams running high-scale MySQL and Postgres clusters, and on one pattern always keeps coming up. As read traffic grows, scaling becomes increasingly complex and expensive, especially when relying on replicas or traditional caching layers. Recently, we published a new customer story with Hustle, where we helped significantly reduce database load and improve performance without requiring any change to their application. It's a great example of how teams are rethinking caching and read scaling today. And that brings us to what we are going to talk about in this session. Today, we are introducing a new and complementary feature within Readyset that we call Shallow Cache. The idea is simple, a capability designed to prove an easy, low friction way to start offloading read traffic and improving performance without the complexity typically associated with caching solutions. So, no need for deep integrations, no need to manage multiple moving parts, just a straightforward way to get immediate gains. We will walk through how this works, where it fits, and how things are already using in production. We are also going to have a quick demo of Ready Set working, and please don't hesitate to post your question in the chat. We will be taking them at the end of the call. With that, I will hand over to Vinny. We will go deeper into the technical details and show how Shallow Cache works in practice. Thank you.
No, now you can hear me. It's glad to be here. I'm happy to be here. I think you guys already saw me. My name is Vinny. I'm a lead database engineer here at Readyset. And as Guy said, today we are going to talk a bit more about our newest feature, the shallow caching. Please feel free to ask questions in the chat. If you want, you can reach out to us. You can send a message in private if you want to know more about the product, how you can use it. Like you can use the social media to reach out to us. We are happy to answer any questions. So let's start with the main purpose here. What is our agenda for the day? So our agenda will be these 4 topics, basically. I don't want to spend a lot of time talking about theory and whatsoever. I just want to show you guys how the architecture works and how you can solve your problems, but I would like to be a bit more hands-on on how to do it. So first, we will try to answer what are the problems that exist nowadays and we are trying to solve. We are going to briefly overview the architecture of Readyset, and then we will go deep into shallow caching, how it works. And I will try to show you a demo how you can work with Readyset. And in this case, I'm focusing more on MySQL, but the upstream database really doesn't matter here for us. All right. So what are the problems we are trying to solve here? Basically, we have 3 pillars that Readyset is attacking and we would like to focus. The first pillar is cost and efficiency. So we all know, like when you're reaching your database capacity, think of, let's talk about replicas in this case. So when we exceed this capacity, what we usually do, we spin a new instance, right? So if we are spending, let's say, $1,000 in the instance, we spin a new $1,000 instance, 1 terabyte disk, for example, 1632 cores, same amount of memory, 32 gigs. And what we do, we start offloading queries to that new replica. What happens is the same query that runs, assuming like everything is with statistics up to date and everything, we run the query that's taking 5 seconds in the first replica, it will take exactly the same amount in the second replica and the third, and so on. So we are spreading the workload in a linear way, right? So we are at the same time we are scaling the costs linearly. The same time, like the performance is increasing in the same proportion. What happens is if we scale vertically, we know nowadays that memory is becoming a very expensive commodity, like DDR5s are being used mostly for AI. So scaling vertically is even more expensive. And in this scenario, the performance doesn't scale at the same proportion, right? It will reach a point where you are putting more dollars, but you're not getting any performance improvement. Our second pillar is how we are the scaling mechanics. So as I mentioned, like we need to replicate the same volume. So we need to do an entire snapshot of the database. And most of the times we will see more in the next slides. We want to cache just a couple of queries from specific tables. They don't necessarily mean they are the big portion of the database. Maybe the table that it's a hot table with just a few gigabytes of data, and we need to spin like our entire data set. And as mentioned, like, okay, in Readyset, ideally what we want is to optimize the queries that are already reaching, they are fully optimized, they have the correct indexes, right? But we know that adding index impact in write performance, right? We have more B3s and everything to keep up to date. And our ultimate pillar, the complexity overhead. So when we start thinking about caching, we think first of Redis or Valky. But what happened with them is like, we need to rewrite the application to handle the data flow. We need to do the caching validation. Like the problem is not caching data, right? The problem is what data to cache, because we have a limited amount of memory, and when to invalidate it and get it fresh. So we will see that with Readyset, we can do this in automatic way, and we relieve this burden from developers and the application. And the third part with ORMs and now AI agents writing code. Usually we don't have the control of the queries anymore, right? They go through the pipeline. Most of the times we won't detect them. We don't have more this fine-grained control. So let's see how Readycache can attack these problems and solve them. As I was mentioned, this is the classic scenario where we need to spin multiple replicas. So imagine like you have a primary instance. Of course, you have your first replica, and then we start spinning more replicas, and this amount of money starts piling up per month. I want to say also, like, we need to be clear with here is that we can eliminate a lot of replicas, but we always recommend like have at least one. And the reason why is Readyset is a caching mechanism. It's not a replica. So if you restart Readyset, you have a cold data, right? You don't have the data there. You need to warm up the cache again. And for backup purpose, right? So you need to run your backup routines, you need a replica. But for all these scenarios where you have multiple replicas, this is where Readyset fits in. So as I was mentioned, we know memory is expensive, but at Readyset, we did a lot of study, not only to develop the software, but also to identify where we can improve. And we believe that here at Readyset, you don't need to cache everything. We identified through statistics and with our customers that often the workload is mostly read-oriented, right? The small portion is write-oriented, and majority of the workload are reads, being for analytical queries or LTP queries. And from this read workload, what we identified is that it follows a Zipf distribution. Think a bit of as Pareto distribution, where we can attack 20% of our queries and solve 80% of our issues. That's basically what it means here. And that's what I will try to demonstrate today, right? So we can cache just a small portion that handles majority of the workload, and then you can already start observing a lot of improvement. So we arrived to Readyset. Readyset, different from Redis, we are a focused SQL caching engine. Here we are going to see how Readyset works. So basically, like, we have different topologies that we can work on, but basically, like, Readyset has zero code changes. What happens is you just need to change your connection string to connect from the database to Readyset. Readyset will do all the offloading of the queries that don't belong to it. We have two caching engines working inside Readyset. We have deep caching, our prime tool, and we have developed Shallow Cache, which provides the full SQL coverage. I will go in more details in the subsequent slides, but basically with these two engines, we are covering basically 100% of read queries going on through the Postgres or MySQL database. And of course, we are providing sub-millisecond reads, right? The idea here is the performance is sometimes even better than Redis, but the idea is to provide data like in sub-milliseconds, microseconds speed. That's what we are working for. And the most important part here compared to other tools, main cache, again, Redis, is that we do not manually invalidate cache. We will see how we are doing this in these next slides. This is an overview of our architecture. So we can see here the application. In this case, I'm putting Readyset in the middle. So it will act as a caching and a proxy. So all queries will flow through Readyset. Everything that doesn't belong to Readyset, which means writes or queries that we don't want to be cached, they will go to the database. How this result is retrieved to Readyset, it depends. So if we are using Shallow Cache, it will come with SQL data, query results. We also have the deep caching where Readyset will behave as a replica using binary logs or raw log files from Postgres, and will behave exactly like a replica. So any change that happens in the database, it will follow the replication protocol and it will update data automatically. So let's dive into Readyset. So this is the architecture overview. I'm not going into details of Deep Cache, but to let you guys know, Deep Cache is our first in main engine, where, as I mentioned, we are using replication protocol to provide up-to-date data in the cache. So we have a data flow engine, which, for example, we get a select query, we decompose it into different states, into partial materialization. So we are using HoxDB, which was developed by Facebook, it's open source, to materialize the tables that we want to cache. And then we are going to have, for example, joins and tables that are decomposed inside our engine. So once we have, for example, select users where ID equal Vini, where ID equal 5, for example, only when I cache this particular ID, this is what is brought to Readyset caching, right? And if there is any update to this, let's say that I changed my address, for example, and it's on the cache. When this update hits the binary logs or raw log files, Readyset will read it and apply the change only for this particular row, right? So it's really efficient, this partial materialization, how we work with that. The problem with Deep Cache is that we cannot, at the moment, materialize all states. For example, complex queries, like several inner joins or sub-queries or a few window functions, for example. At this moment, we do not have support in Deep Cache. And for that, this is why we decided to bring Shallow Cache, because then we can cover all the other queries that Deep Cache at the moment cannot do. So we are offering two options. of working. So with deep caching, we have sub-millisecond updates. With shallow cache, we are providing you with thunderhard protection. We'll go over this. We are giving you refresh interval and everything, a very low granularity, so you can work on this per query, so you can have everything covered. Did I get any questions or not? If not, I will proceed. So let's take a look at the architecture overview. Now we are talking specifically about shallow cache. So this is a scenario where Readyset is working, but we don't have the query cached, right? So what happens is the application sends a query. Readyset will tell, this doesn't belong to me. This query fingerprint, like the query fingerprint is basically the ID as we know in performance schema or proxy SQL, we have like a identity, a hash of the query. So this query doesn't belong to me. So database, please process it. So let's imagine this query takes 23 seconds. The database will process it normally, and will send the results to the app. No surprise here. Now in a scenario where we want this query to be cached, right? The application sends it, Readyset says, oh, okay, this belongs to me, but I don't have the data that you want in my memory. Like it's a first hit or Readyset just started. So we will send this query to the upstream. It will take the same time to process, no surprises here again, but this time we are going to store the result in our memory. And we are going to send the result to the application, right? Remember, query, caching, we need like repeated queries, right? This is the default for any cache. Like if you are hitting for the first time, it's a mishit. This is what happens in processors. Like if you don't have the data in your L1 cache, it will go to L2, L3, run. If not, it will go to the disk. So it will cascade. Same with Readyset. But this is what happens now. We have the cache. So we have a couple of scenarios here. The one that is similar to any caching is, okay, I have the cache, and in this case, I'm using the full settings, right? So I have this data here it is. So Readyset will provide the results in like 5 microseconds. It's wonderful. Like blazing fast, it's the perfect scenario. But now, the cache is working, we're receiving more workload. And let's say this query arrived between 5 and 10 seconds. This is our refresh parameter. And this is where our magic is going to happen, right? So it's here. What will happen here when we see, and this is our main technology works, is we have an architecture here, what we call left-right pattern. So our data will be there. So the request will arrive inside Readyset, and we have 2 pointers. So we have 2 copies of, we have 2 slots of the data. So we have the most recent one, what we call the left copy. So at this instance, data will be served immediately to the reader nodes, to the reader requests. So no locks, everything will be served in 5 microseconds. At the same time, what will happen is Readyset will send a sync request to the database. And what we are going to do is we are going to fill up this right side. So at the moment the request arrives, what Readyset will do, it will change the pointer to the right side. And so we will start having fresh copies of it. And it will be like with what we call atomic swap operation. We won't see this happening for the application. There is no locks, no anything is happening. So for the application, this is completely transparent. Like think of a train in the rail. When you change it, the passenger doesn't notice like the change, right? That's exactly how it happens here. And there is a scenario where like the query took a lot of time, right? So maybe what happens is our memory got full. What happens after 10 seconds by default is the data will be marked for eviction, which means is okay, my memory is full, right? So if somehow I need to take this data out of memory, you are eligible to be evicted. So this will follow the same process as a first hit as well. If the result is in cache, it will be served, but if it not, it will follow the same state as a first hit or a cold cache, right? Because the data was evicted. That's what happened. And this is fully automatic. That's what happens with Readyset. Like we don't need to do any validation process, anything. The application doesn't know how this is going on. And this is an overview for those who are interested. What I put up here is the parameters I was mentioning, right? We have a refresh of 5 seconds. We have the TTL. And what we have here as well is we have a Thunderbird protection. So what means is the query is expired, right? It was evicted from the memory. And then suddenly what happens with Redis, for example, the cache is expired. You have like 100 connections arriving to the database asking the same data. What we provide by default is a coalesce. So which means is we got 100 requests, Readyset will say, well, hold on, I will send one request, you guys keep waiting during this coalesce time. I will get served this request inside the coalesce time. I will feed our requests with this data. So we are not causing spikes to the database, right? We don't have like 100 requests at once. Coalesce provides us. What happens is if this timing is not respected, then Readyset will not hold these guys forever, right? To say, okay, I don't got the messenger from the database, you guys can go and ask. This parameter is configurable as well, right? So we can define it according to each query, right? So this query can wait for 1 second. Maybe my analytics query can take can wait for 1 minute. We can define this per query. So continuing with it, let's take a demo. Let's briefly look at a demo. While I'm preparing, if you guys have any questions or not, I'd be happy to answer. And okay, I assume you guys are seeing my screen now. You have up here, I prepared a quick finance demo. And here below, what I'm going to do is I'm going to set a caching in my local machine. So the idea here is I want to show you guys how quickly we can set Readyset for testing. And to do that, I'm going to use pip. If you're using Linux, you're going to use pip3, but in this case, I'm going to use pipx because it's macOS. And I'm going to install RDST. RDST is a tool that we developed. We are going to announce it, make an announcement public soon, where you guys can test it. It is embedded with AI. It can analyze your fleet and provide improvements to it, and we can quickly test Readyset as well. So let's see how it goes. First, I'm going to install RDST. And while it's installing, let me get the information. So RDST is installed, and now I'm going to configure. So RDST is going to ask us a few questions to configure the database. So we are in, we don't have any targets. I'm going to define here a name for this target, Vini demo. Just 1 second. First, I don't want to use passwords there. So first, what I'm going to do is I'm going to use define environment variable to define my password. And then I'm going to configure Readyset. So I'm going to use Vini demo. I'm going to use, I have RDS running in AWS, so we are going to connect there. It's a MySQL instance. I'm going to fill up with my host here. The port is the classic port. My database name is demo, I already know. My user is admin, and I'm going to use my environment variable, right? I don't want to spend time here. It is Vini demo password, my environment variable. And for the rest of the options, I'm going to use the default options. This question about read-only connection, why it exists? Remember in this, and I'm also going to use this as an example. Readyset will be a proxy. So if I receive an update or a delete, I want Readyset to handle it. It won't process, it will do the bypass. But the connection from Readyset needs to be able to handle the writes, right? So we need the same privilege as the application. I don't need to set as default target because with our DST, we can have multiple targets. It doesn't matter for our demo. So I'm going to save this configuration. I'm connecting, so my connection was successful. I'm running on MySQL 848, and this is the most important. I want to set up a Readyset cache because I want to start testing it right away. So I'm going to reply yes. Remember, for this, you need to have Docker running on your laptop or your machine, right? If you're using Linux. So I have my Readyset cache running. So the deployment in my case, it is really fast. My image is already deployed because I was testing yesterday, so I don't need to fetch the Docker image from the internet. But for you guys, it should take like just a couple of seconds. Same if you already run Postgres or MySQL in Docker environments, you know, it spins really fast. Okay, so I already have my instance running. What I'm going to do here is I prepared this demo here. So I'm going to start it so we can work on it. And just to show you guys, this is my demo, right? So I'm going to start with 25 threads simultaneously, and I'm going to start the workload. So we have my workload running in both at the same time. So we can see here, MySQL and Readyset, they're running about the same speed, right? There is some small variation. Remember, like I'm collecting metrics, I think every second, if I'm not mistaken. So like we don't have this millisecond granularity. I would overload my PC and the database instance just to collect metrics. So I have set with 1 second. So we can see here what is important. Our TPS is almost the same, like no surprise here. And the latency we can see like is slightly higher for Readyset, right? Because it takes a couple of microseconds for us to process and like, okay, this doesn't belong to me. Database, please do your job, right? And then the result comes back. That is fully expected. So in any nature, if you're monitoring database or if you're adding one more hop, like you need to take in consideration this extra amount of effort, right? To have more code in front of the application. If you're putting this proxy, let's say you have your application in United States, then you decide to put your Readyset in Europe and your database is running in Asia. You need to take into account all this latency that goes over and over, right? We still did not find a way to break the law of physics here. Now I have Readyset running in my local instance. I can connect with my SQL client. We can see here that I'm connected to my SQL instance. And I want to show you guys 2 commands. So the first one is show proxied queries. What basically show proxied queries will bring to me are queries that are passing by Readyset, but he's not working on that, right? He's basically a watcher, right? Okay, this is his view. Okay, guys, this is what I'm seeing coming through, and these are the queries. So if you have updates and deletes, or if you have like commands here, like show databases, let's see if I have here. And if I run show proxied queries, I have select database. So I have administrative commands as well, right? So we have all of these here. And the other one which I want to show you guys is show caches. I don't have anything cached, so it is empty. At the moment we start caching queries, we are going to see them here. So let's take a look in our application, right? So we are doing the same KPS. I have put 40 queries here, and what I try to do here is that they were trying to follow a zip fee and the distribution. Remember, this is a syntactic workload, but I try to bring it as close as possible to a regular workload. What means with the zip fee? Remember, I want to address 20% of my queries to solve the bigger portion of my issues, right? So I have my 4 top queries. If we make a quick math here, it is probably like with 4 queries already handling mostly 50% of my workload. So let's try to cache one query. So I'm going to do create cache from, and I'm going to put my query here. So I created my app. I already put as a cached query because I'm checking my proxy, my Readyset instance every second. So my application is able to detect when a query is cached. So I'm handling now 23% of my zip fee and traffic. And we already can see that I'm performing like 50 queries per second more with just one query cached, right? Here, what we are trying to do is imagine that these instances are operating at maximum capacity. So Readyset here, it can replace one read replica, right? For a tenth of a cost, we already can serve, remember the $1,000 replica. So we already can serve with a fraction of a cost 1 or 2 instances just by caching one query. Let's cache one more manually. Create cache from my query. And if I do show caches, we will see we have 2 rows, right? Naturally, remember what I said about query ID? This is what Readyset has, right? So you get the query IDs, oh, this query belongs to me, oh, this query is cached, and we'll handle all the workload here. And when we look here already, so we are handling 35% of the zip fee and traffic. We are almost performing 100 queries per second more than MySQL. And Readyset already is handling the workload of 2 replicas, right? Basically, like we are replacing the effort of 2 replicas. And remember, in this instance, it's a Docker instance running on my laptop. I didn't need to do a new replica, set up a new instance with gigabytes of memory and everything. It is running right away and just using a fraction of memory, right? To facilitate here, as I mentioned, we still have here show proxied queries. So we still have a lot of queries here to cache, right? I'm not going to do one by one. I hope you guys already got it. This is the command, right? So if you want to run, it is how it's going to do. If you want to remember the parameters I mentioned, so by default, the TTL is 10 seconds. It will refresh every 5 seconds. And the Thunderhead protection is 5 seconds. I can change this per query, right? So every time I'm creating the cache, I can specify. Let's try to do something. I didn't do this before, guys, so I beg your pardon if it doesn't work at first, but I didn't test. Let's say I want to put this for 20,000. Yeah, it didn't work. I'm not going to remember now from the top of my head the syntax, but we can change it per query, right? I don't want to index every query here. In my application, I decided like I can cache per per traffic. I can cache everything, but let's suppose we are doing respecting the zip fee and distribution, and I want to cache the top 20% of the queries. So 20% of 40 queries, it's 8. So I have 8 queries cached here. And we already can see my Readyset spiking and doing at least the double and more of queries per second, right? So this, by just following zip fee, and remember, this is synthetic workload. My queries doesn't like, are not, I try to make them meaningful, but the data is somehow fairly distributed. So so we have the like 2 times more the workload, 3 times more the performance improvement. And not only that, when we look latency, like this is overall, right? So just have this in mind. The per query would be like, we have 100x, 200x performance improvement per query. Here I'm trying to show you like a average, a median of like how the performance can improve, right? So what I'm going to do is I'm going to try now to cache half of my queries. Now I have 22 queries here. And now, like, we can see that with half of our queries working, our KPS is like really spiking. Now we are like 7x more. We are replacing at least like, let's say, work with the lower number, 7 replicas at least, because it's going to 7 and 8. So this is the amount of money that you can save like in instance right away. Remember, you need to have at least 1 instance, guys. You need to do backups and everything. We're not telling you to eliminate everything and work with like only Readyset. Like it's like using hide 0 on your disks, right? We don't want this extreme performance at high risk. So yes, we need some redundancy. You need to have at least 1 replica. But for all these other 7s, you can work with Readyset. And that's what we want to show you here. I have set Grafana as well. So this is Grafana. As like, because it's a zip fee and redistribution, we can see the cache traffic approaching the zip fee and distribution. We have 20 queries cached, the other ones not. The number of clients, I put some annotations so we can see here, the moment we set the configuration, we can see the Readyset KPS is spiking, you know? So we can see, and then it hits a plateau where it stabilizes, and that's where we get the maximum for performance. We have some latency metrics here as well. At the moment, we starting caching more queries, we need to refresh those as well. They are synchronously, right? Each query has its own timer. That's why we are not seeing 20 here. So even though like this is not arriving 20 queries every time at the same time. So this is good as well. We are not bringing the workload to database at the limit. So this is a synchronous refresh as well. This is the idea, right? And like, if you're guys like curious, if I try to cache everything, like if I go hard here, what will happen is like, then we have like, we explode the number of KPS, right? So then we get notoriously impressive. Of course, this is the ideal world. If you're working with analytical queries, this is, for example, let's say you have analytical queries that run on D-1. You can have your Readyset refreshing all these queries during the night. And in the morning, when you need to extract this data for your BI or something like this is the response time you're going to have, right? Now we have 0.7 milliseconds, and my SQL is stuck at 150 milliseconds. What is the magic here about latency and such? It depends on your architecture, right? In this case, I put Readyset running together with my application. So all this latency effort is done in the background. It's asynchronous now. So the application doesn't feel the latency anymore of Readyset. Of course, if you put Readyset in the database side, you will still suffer the latency. So it really depends of the topology that you are working, how you are designing your architecture. If you have any questions on that, we are happy to help as well, defining what's best for you. And then like here, of course, we see the throughput, it really spikes and like it gets really crazy. So we can get a lot of performance, right? So everything, the draft, the panels just get as good as possible. Now I'm going to stop workload. This is what I wanted to show you guys, and I'm going to bring the slides back. We are approaching the 40 minutes of the session. So I'm going to open for questions for you. And while I'm trying to answer the questions, I will ask you guys to follow us, me and Guy. Readyset is here. As I mentioned, you have to run only 2 commands to test our DST. There are a bunch of new things cool things we are putting there. I'm just showing you the basic, like with 2 commands, you can set up Readyset to run your instance. But now I'm happy to hear your questions.
Cool. So we are going to run with this first question from Akshay Kumar. Is our DST a free tool? Can anyone use it, or do I have to pay for it like Claude? Do you want to answer, Vinny?
Yes, for sure. This is completely free to use. So you can download even Readyset. It's at GitHub. You can use it. You can put in your production. All tools that we have available, like we have the binary for Readyset in GitHub. You can download and test. By the way, we are happy to receive any feedback. Or if you built a war story for your company using Readyset, we are happy to post it. So if you have something cool, you did something amazing with Readyset, just let us know. It's free to use, and both are DST and Readyset. So please, if you are using, please let us know.
Okay, the second question, is there support for MongoDB from Maya Bennett?
Unfortunately not. We would like to have. If there is a lot of people willing to do it, we are happy to hear. Of course, if there is a demand, we would love to support MongoDB, but no, at this moment we are supporting Postgres and MySQL.
Yeah, but just to complement the question, if you have such a need, reach out. We'll be happy to talk with you. Okay, next question. Does Shallow Cache have any tool to monitor hits and misses? From Heydrich Oswald.
Yes, actually, there are 2 things here. So the first one, Readyset by itself, we have Prometheus running. So we have a port open. It's the port 6034. So if you do curl there, you can fetch Readyset metrics. You have query hits, query misses, you have memory usage, have like really, I think it's more than 200 metrics or something like this. It's really a lot. And we also have Grafana. We already built a dashboard you can download as well. We provide this for free. So it is easy for you. Don't need to develop your Grafana dashboards. We already have a pre-built version of it. But in case you already have a monitoring instance, we have Prometheus. You just need to connect to the port and start feeding the metrics to your monitoring system.
Okay, is it possible to turn on better performance on a complex query using no operator like with using the caching? From Marcio Costa.
Hey, Marcio, glad to see you here. I know you for a while. Hope to see you in the next MySQL conference. But to answer your question, yes, it is possible using Shallow Cache, right? We are going to cache this, but keep in mind as a recommendation, right? Try to, if possible, try to optimize your queries first with like index or even like with better, maybe rewriting the query. Like ideally, these queries, because we don't want to overload neither Readyset or the database, right? But yes, you can, and we understand that there are situations, as I mentioned, like especially using ORMs or agent AIs, that we don't have this full control over the queries. So we can serve these queries that are not optimized, perfectly optimized at this point.
Okay, next question. How is this better than Redis? From Akshay Kumar as well.
Okay, great question. I think I covered it a bit during the presentation, right? So here I'm not here to start a battle with Redis. Like Redis is great. It has your specific ways where it works great. But what I believe where Readyset excels with this is because we are a SQL caching engine, right? And by that, we are specialized in doing this better, you know? Why? We understand the database protocol, as I was showing here. So we understand the queries that are coming through, we know how to route them, and we know how to handle them. And most, the special part here, we took special care in handling caching validation, right? So we are doing this inside Readyset. So you don't need to code, even with like, oh, okay, you have cloud, you have everything at your hand today. I can do it. I can ask my agent to do. Yes, but like you are adding complexity. So you need to configure ahead this cluster. You need to handle this caching validation, and you are adding more components to your infrastructure to make it more complex. With Readyset, it's simple. Like you just connect to Readyset, and we treat everything inside SQL. So we are working this. All the invalidation and everything is handled inside by a single component.
Okay, next question from Kumar Pratek. Do we observe the same performance benefits for aggregation queries like count, sum, average, as we observe it for select queries using the shallow cache?
Yes, we do. We will observe the same because remember, shallow cache, unless we are talking about the first hit, because the first hit or cold cache, what happens is, of course, I don't have this data in memory. I need to get to the database. So it's a mishit. And a mishit, there is not much we can do. We need to request this data from the database. But once it's in memory, the entry ID is there. So you run this cache, this query again, Readyset will tell, okay, I have this data. It's here. So we don't need to parse the query. We don't need to do any aggregation, anything. It's already there. We already computed the data. This is why the data, once it's cached, we can serve in microseconds.
Cool. The next one from Maya Bennett. How many replicas on average do you see saved?
So this is a great question, and I think I can show here is like it really depends of your workload. But when we do, for example, 20% of queries, this is a syntactic workload, right? And we already can see that we are saving at least 3 queries in my demo, 3 replica instances in my demo, right? So we have real cases. I invite you to check our Readyset page where we have a case study from ClickFunnels where they were able to save, this is a real world scenario, where they were able to save, if I'm not mistaken, 6 or 7 replicas from production, right? They were using auto-scaling. So we were able to save like $1,000 for them and improve the performance like by I think 30x or something like this. So I invite you guys to follow our page and check our use cases as well.
Cool. The next one from Akshay Kumar. Is this all from a single instance of Readyset, or is this distributed system like Aurora?
This is from a single Readyset instance. Remember, I deployed Readyset in my laptop, right? This is not even, let's say, a production-ready instance. Let's say you are replacing your replica with let's say you have 7 replicas, you are replacing all of them with one single instance that would have the same capacity as one replica. Then you can have it. Like you of course, we don't have native like Readyset cluster, but you can set multiple instances to avoid, like having a single point of failure.
The next one, does this work with proxy SQL?
Yes, great question. It works, and it works even better. We have a tool called Query Pilot, which is for those, as I mentioned, like I don't want, for example, I don't want to have a DBA or someone to keep analyzing my show proxied queries and deciding which query to cache. With Proxy SQL and Readyset, we have a tool called Query Pilot, which will keep analyzing the queries passing through Proxy SQL, and it will automatically cache these queries for you. So you have, let's say, a free hands-on. So you don't need to, like, it's your Tesla for caching queries. So Autopilot, the Query Pilot will do everything for you. You just need to sit and watch the improvement.
Thank you, Vinny. Let's take this last one. So what if I don't know which queries need to be cached? Does Readyset handles that it or caches everything?
Yeah, so Readyset by default, it won't touch your workload, right? As default, we don't want to cache queries that you need, let's say, MVCC or a high level of isolation. Readyset is there when eventual consistency is okay. So if you're already using replicas to offload queries, this is where you need to consider Readyset, right? This is the moment. And as I mentioned, like we are not going to cache those for you, but if you want, you can use Query Pilot. And with Query Pilot, it can automatically cache the queries for you. Of course, it won't cache everything. We have a few options, like I want to cache the queries that are running for longer. I want to select a model where I want to cache queries that are running multiple times per second. So we have some options to define Query Pilot to decide which ones you want to have cached. So we try to offer you both options. If you want to do it yourself, you can do, or if you want to delegate to Readyset and Query Pilot, you can use this option as well. Remember, Query Pilot is also you can use it in your production. You are free to test. We are glad that you test, and you are glad that you talk about. So feel free to use any of these tools. If you have any questions, guys, running any of them, you can reach out to us in social media or send me an email or anything. Or GitHub, you can report issues or feature requests there as well. We are happy to improve the product and make it more appealing and easy for everyone to use.
Well, thank you everyone for joining us in this webinar. I really appreciate all the thoughtful questions, and we are super excited about what we've been building so far with Readyset. We will share a lot more on our DST in our next webinar. Please stay tuned. Thank you all.